Alright, so here we go with more application practice. What we're trying to do here is look at different types of application problems. In this case, mixture and motion problems. I like to divide these up into different types of looks, so that way y'all kind of develop your own strategies, and then hopefully you start being able to do this just straight translations. But let's look at what these are. Now, with mixture problems, you have two types of equations. You have a total equation that will always read x plus y equals the total. For pretty much all the examples you're going to see, that's what you'll see. You know, that you'll have something that has a total of this, and you have x plus y equals that total. Then you have a mixed equation, where it's basically like the total equation, but you've got some number times the x plus some number times the y equals some number times the total. So they don't really deviate from this. So kind of keep that in mind for your mixture problems. So let's look at our first example. Candy worth $1.05 a pound was mixed with candy worth $1.35 a pound to produce a mixture worth $1.17 a pound. How many pounds of each kind of candy were used to make the 30 pounds of mixture? First off, it does help to understand what your x and y are. So here I decided, okay, the x should be the candy that's worth $1.05 a pound. So I wrote there, candy, let x equal the $1.05, the $1.05 candy. So $1.05 a pound, or $1.05 per pound. Y is the $1.35 candy, because you're mixing those together and you're getting something that's in between. And keep in mind, these are pounds of candy, which is really a lot of candy when you think about it. 30 pounds is a lot of candy. Anyways, so you have this right here. So if we go to that idea, then the first thing we need to think of is that there should be an x plus y, our total equation. There's always going to be a total equation. X plus y equals how much candy are you buying? What's the total? And if you go back and look at the problem, it'll tell you 30 pounds. So you put equals 30. Rewrite that equation for your mixed equation, but put spaces. And in those spaces, you're going to put the numbers that should multiply. Well, what goes with the x? Well, the x is $1.05 candy, so that should be $1.05. The y was $1.35, so put the $1.35. And the mixture, the 30 pounds, when you put them together, came out to $1.17 a pound, or $1.10 a pound. Let's see, what was that again? Let me go back and look. $1.17 a pound. I'm not exactly sure why I put $1.10. Let me check that real quick. Okay, so that is $1.17, and apparently I wrote $1.10, which would have messed up my whole problem. So I'm going to change that to $1.17 a pound. That's 1.17. Okay, go with that. All right, so if I multiply those, I got $1.05 x plus 1.35 y equals 117 times 30. Let's see. Equals 35.10. Okay, if I bring this other one down, x plus y. Actually, I'm going to do it this way. I want to bring this other one down, but I want numbers that are going to match up so I can do this by elimination. So I'm going to decide what variable I want to get rid of. Let's say I decide to get rid of the x. So I'm going to multiply all of this by 1.05 negative. So that way I have negative 1.05x. That way I know my x's are going to cancel. Negative 1.05y equals, again, negative 1.05 times 30. Negative 1.05 times 30. Now I'm doing this with the calculator, so kind of keep that in mind. Negative 3150. Okay, so these cancel. It leaves me with 0.30y or 0.3y is equal to 3510 minus the 3510 minus 3150 gives me $3.60. Divide by 0.3, and I get y is equal to 12 pounds. Okay, I'm going to put that 12 back into either equation. It would actually be fairly easy to put it back into this equation and say x plus 12 equals 30. So then you subtract 12 and you get x is equal to 18 pounds. So the idea there is that you're trying to find, say, two totals. Now look, 18 plus 12 is 30, and you could do $1.05x or $1.05 times the 18 pounds plus $1.35 times the 12 pounds, and then see if that equals $1.17 times the 30 pounds to see if this would be a reasonable answer, which it should. So there you go. That's the mixture problems. They don't really deviate from this, and if you do have more questions, feel free to ask. Write them down and let me know. But let's look at another example. The next problems are going to be motion problems. Motion problems deal with, like, say something like your speed and stuff. So usually there's two equations with this one also. One equation talks about you going with something. Like if you were running track, when you got, or like if you were biking, if the wind is behind you and like it's going in like the same direction as you're going, it makes you go faster. So it adds to your speed. But if it was going against you, blowing against you, it would work against you and slow you down, so it works against your speed. So we'd look at it like that, where we say the time, t, and if I was going with, I could say x plus y. So I'm saying like the wind is with me. It's going in the same direction as I am. So it's adding to my speed. Against would be minus y. And these should equal distance. So you can kind of see here what I'm trying to say is that every single time you should have time and either x plus y equals d, and then the second equation of time, x minus y equals d, the distance. T is time, d is distance. That won't change. I should always get those type of numbers. So x, again, is your speed, or the speed of whatever person you're reading about. Y is like the other speed, like let's say if you're traveling in the water, the current, or if you're going with the wind, the wind speed. Now, some key words to remember here. This is very key. Downstream means it's going with you. Like if you're in the water and you say you're going downstream, you're going in the same direction as the current, so it adds to your speed. But upstream means you're going against the current, which means it slows you down. That would be subtraction. With the wind, against the wind, you kind of see the idea. So, let's look at an example. Jim can row 30 kilometers downstream in 3 hours, or he can row 18 kilometers upstream in the same amount of time. Find the rate he rows in still water and the rate of the current. Okay, what that means is, find the rate he rows in still water. That's his speed. What's Jim's speed when he's rowing? Row, row, row your boat gently downstream. Anyways, so we're going to let x equal Jim's speed. Jim's rate, let's say. Rowing rate, or rowing speed. Now let y be the water current speed. The water's current. How fast is the water current? Because it does. If it's going a certain amount, it can work with you or against you. All right. So how do I start this off? Well, I should say x plus y, x minus y. That's my beginning. Remember, x is Jim's speed, y is the water speed. Okay, how long was I rowing? Well, I was rowing 3 hours. Downstream, so this one would be downstream, I would go 30 kilometers. Or in that same time, 3 hours, if I'm going upstream against the current, I could only go 18 kilometers. Okay, I see parentheses. What do I do with that? Well, I would go ahead and distribute and get 3x plus 3y equals 30, or 3x minus 3y equals 18. Notice my y's can cancel out. I got 6x equals 48, and I can divide by 6 to get x equal to 8. And that's kilometers per hour. That's how fast Jim's going. Now I can put that into the first equation and say 3 parentheses 8 plus y equals 30. Notice all I did was put the 8 in place of the x. Go ahead and distribute if you want. 24 plus 3y equals 30. Subtract, then divide, and you would get y is equal to 2 kilometers an hour. So that tells you that Jim can row by himself. If there was nothing against him, he could go 8 kilometers per hour. But with the current, the water current is going 2 kilometers per hour, and that's changing how fast he can actually go in the water. So that's pretty much it for the motion problems. They really don't deviate from that too much either. So just kind of keep that in mind, and if you do have any questions, feel free to ask. But that covers the last 2 pages of the worksheets that y'all need to be working on. Thank you very much, and hopefully this answers all your questions.